Okay, well, I am a global climate change scientist. I'm proud of that fact. I have been for almost 50 years now. And as was mentioned, I do most of my research in Antarctica. I first went to Antarctica in 1970 as a graduate student. Have been back more recently, and the changes that I've observed during that time are truly phenomenal. What I'd like to do today is sort of give you an overview of global climate change science, what it means, and how we might confront skeptics. Because as we well know, there are many skeptics. We currently have a president who believes that global climate change is a conspiracy among Chinese businessmen, which is an outrageous hypothesis, I might add. As you will see, it is very difficult to refute global climate change, which is why 98% of scientists are in agreement that global climate change is real. The other thing I'm going to try to convey to you is the fact that this is not a prediction. This is something that's happening today, and it's happening at an extraordinary rate. It's impacting our lives even today, as our last speaker so nicely conveyed. Well, we have initially what we call global warming, which was the first literature that came out on this topic, focused on temperature changes. And certainly temperature changes are important, but as we'll see, they're only part of global climate change. So that we've now adopted this term global climate change to include other factors like drought, for example. And in fact, many of the skeptics of global warming would argue that, well, it's actually getting cooler in some places, and that's in fact true, because the distribution of heat across the Earth's surface is not the same. This is the famous figure that Al Gore showed in his movie, his video, where he got up on the up on the ladder and showed this what's called a hockey stick, which shows the dramatic change in temperature that occurred in historical time, more recent historical time. And the cause of this, even though it is refuted, is not really rocket science. We've known about the greenhouse effect for over 100 years. And if you've ever been in a greenhouse, you know that it works, right? And so it's not complicated. The Earth receives radiation from the sun. Portions of that radiation are in the infrared spectrum, and that radiation doesn't escape. All of that radiation doesn't escape because of greenhouse gases. As we add greenhouse gases to the atmosphere, we have in essence the effect of building a greenhouse, putting the glass there to capture the outgoing radiation. Now, the cause is also not disputable. We have been measuring CO2 concentrations in the atmosphere for over a century, and it's very clear that those CO2 concentrations, actually we've been measuring CO2 concentrations directly for less than a century, but we have a record that goes back far beyond that. And what this shows is the variations in CO2 concentrations in the atmosphere based on direct observation from Mauna Loa in Hawaii and from ice cores that takes us back to 1880X, as we'll see much further back in time. And you can see there's a strong correlation between CO2 increase and temperature. That's scientific fact. It's not debatable. We can actually go farther back in time because using ice cores. Now, ice cores allow us to go thousands and even hundreds of thousands of years back in time, because when ice forms on the ice sheets and on glaciers, the ice captures air bubbles, and we can actually analyze the air bubbles that was captured thousands of years ago for their gas concentrations, including CO2, methane, etc. And so using that technology, we can actually go back thousands of years in Earth history and see how CO2 has varied. And in fact, there's a very strong correlation between, for example, CO2 concentrations in the atmosphere. In this case, we're going back 600,000 years in the ice core record. And you can see a strong correlation with CO2 and temperature on Earth's surface, which is also measured from ice cores. So there's no dispute about this. Now, this was actually used by the skeptics of global climate change as an argument against climate change. The argument, I call it the Sarah Palin argument, that says, well, Earth's climate has always changed, so why would you argue that humans are responsible? And pointing to these kinds of data. Well, Sarah didn't look closely enough at the data. And had she looked closely enough, she'd have seen that these are those sort of natural variations in CO2 concentrations in the atmosphere, and look what's happened in historical time. So in historical time, we have increased the CO2 concentrations in the atmosphere far beyond any natural levels for the last 600,000 years. That's an extraordinary thought when you really think about it. I want to talk a little bit also about the impacts of global climate change. Again, not global warming, but global climate change. Because global climate change involves not only increased temperatures, that's part of the phenomenon, but it also results in rising sea levels, which are related to temperature, certainly, but as we'll see. Drought, water supply, as was mentioned by the previous speaker, and of course, habitat changes of organisms. All these are impacts. There are other impacts that we don't even talk about very much. We could come up with a long list. For example, I find one of the most frightening impacts of global climate change is the fact that the CO2 that's being incorporated into the oceans, and the oceans are the ultimate sink for the excess gases and the temperatures that are being created by global warming. So the oceans are getting warmer. They're also getting more concentrated with CO2. That means the oceans are getting more acidic. And the response to that is that we're starting to see widespread evidence now of corals, reefs, starting to disappear because the oceans are getting more acidic. And that's a very well-established pattern. Drought is a phenomenon that we're all familiar with here in Texas for sure. And people might argue, well, we're beyond the drought now because this year we had record rainfall. So that just goes to show you, global climate change folks, that you're wrong. Well, no, it doesn't show that the global climate change is wrong. In fact, most models for global climate change calls for extreme variability in precipitation, not just drought. And we are, in fact, seeing extreme variability as predicted by the models. So there's nothing new there. We're seeing this year record rainfalls. But certainly in the past, in the recent past, we've seen extreme drought. We worry more about the drought. We worry about both because with extreme rainfall comes flooding. But of course, with drought comes water shortages and issues with agriculture and wildfires. There's a direct correlation between wildfires in the U.S. and other places as well, but certainly in the U.S., a four-fold increase in wildfires in the U.S. in the last 30 years, which is related to droughts, directly related to droughts. But we can actually, like using ice cores, we can look at tree rings, and there are trees that are 1,000 years old. And the tree rings represent annual growth of those trees. And when we study the people that study these tree rings, and there are people that spend their careers studying tree ring history of climate change, see these dark bands which represent times when the trees were scorched or burned. And so by counting the annual layers in the dark rings, we're able to point out that these folks are able to point out that wildfires have been increasing at an unprecedented rate over the last 1,000 years. Now, these are results, everything I mentioned so far, are results that are published in journals like Science and Nature. So this is not a science conspiracy. That's hogwash. Believe me, somebody's been a scientist in the sciences for 50 years. Scientists never agree on anything, and the mere concept that there could be a conspiracy, an international conspiracy, is outrageous, simply outrageous. Now, I don't want to convey to you that scientists understand all the implications of global climate change. For example, one of the theories that has been put forth is that we will see more hurricanes and more intense hurricanes as a result of global climate change. That's one theory. There are scientists who argue we'll see fewer hurricanes, not many. But what the record seems to be telling us is that we may not see an increase in the frequency of storms. In fact, it's more complicated than that. We're probably going to see a shift in storms more to the higher latitudes. We'll see more Sandys, more New York, North Carolina, and to the north, and even hurricanes impacting Nova Scotia eventually, but probably fewer hurricanes impacting the Gulf. But the ones we'll see will be megastorms. They'll have more energy because Gulf waters will be warmer. My field of research is sea level rise, and this is sort of the poster child for sea level rise. This is St. Mark's Square in Venice, and there are a lot of sea level conferences in Venice because everybody likes to go to Venice. But if you go in November, this is what you experience. You wear boots and you walk on platforms that are built about 3 feet or so above sea level for the tourists to walk around. The skeptics would say this is not related to global climate change. This is not due to melting glaciers. Well, to some degree that is true, but it is related to global climate change. It's not related to melting ice sheets and glaciers. It has to do more with changes in circulation patterns in the Adriatic Sea that are causing these phenomena. But you can pretty well guess that when they built St. Mark's Square, they didn't build it below sea level. So something has changed, and what has changed are these oceanographic circulation patterns, and those are in fact related to global climate change. Now actually, sea level is one of the most compelling lines of evidence for global climate change. I love to use it when I'm in debates with an audience like this, and I've given talks like this to groups that were largely skeptics, heated discussions taking place. I actually kind of like those because that's where you really have to make some headway in terms of converting people. But sea level is what I consider to be unrefutable documentation for global climate change, and it's an eye-opener for the dramatic rates at which climate change are occurring. Here is a sea level curve for the last a little over a century, and you can see that sea level, like atmospheric temperature, has been on the rise. This is based on tide gauge records, so there's a lot of variability because tide gauges measure not only the level of the water, but they measure the level of the water, but the level of water relates to tides, to sea level, and to wind forcing. So there's going to be some variability, but if you look at the overall trend, it's going up. The last red line here shows the data that are actually derived from space, from satellites that are now capable of measuring rise in sea level. And of course, they support these tide gauge records. And what those records tell us is that globally, world sea level has been going up at a rate of 3.3 millimeters per year. There are places where it's actually going down, as we'll see, but so that's an average. Now, if we take that and then we predict what it will do in the future by extrapolating that. Now, if we take that red line and we extrapolate it out, that suggests that by the end of this century, sea level will rise about 0.5 meter, about that much, by the end of this century. Doesn't sound like a lot, but to barrier islands, that's very significant. That will spell the end of some of our barrier islands along the Gulf of Mexico coast, both Mexico and U.S. In reality, we now know we're more on this trajectory, which is probably going to be closer to 1 meter of sea level rise. And we also have, like in the case of the ice cores, we have records that allow us to go back thousands of years. In this case, not ice core records, but algal mats that form in lagoons and places like that form right at sea level that we can date using radiocarbon dating with greater precision than we were ever able to achieve before. And what those records show is that if we look at the last 8,000 years of sea level history, the rate of sea level rise has decreased because the ice sheets got smaller. They were melting. They've been melting, and they're starting to melt at a slower rate. But that the rate of rise over the last 4,000 years was about 0.5 millimeter per year. That indicates that there's somewhere between a 5- and 6-fold increase in the rate of sea level rise in historical time. Never in the geological record are we able to see that kind of acceleration in the rate of sea level rise. Now, what's causing that? What causes the oceans to rise that rapidly? Now, again, if you talk to the skeptics, they'll say, well, this is not new. Sea level's always gone up and down. Yes, but it has not gone up and down at these rates. It's gone up and down hundreds of meters over geological time, over hundreds of millions of years, but these are unprecedented rates. And what mechanisms can cause sea level to rise at that rate over this time frame of a century or two? Heating of the oceans, heat water that expands, and melting of glaciers. Now we look at the scientific evidence for this. We see, in fact, the oceans are getting warmer. We've been measuring ocean temperatures for almost a century now. We know they're getting warmer. And we can take those trends in increasing temperatures of surface waters, and we can actually calculate quite independently how much the oceans will have expanded or would have expanded over the last century. And we can also observe the distribution of those temperatures, which is what this map shows. Now, the orange areas here are areas where it's actually where the oceans are getting warmer. The blue areas are areas where the oceans are actually getting cooler. So that heat's not being uniformly distributed because of ocean currents that are moving around and distributing that heat in a non-uniform fashion. Glaciers. 87% of the glaciers in the world today are in retreat. That's not prediction, that's scientific fact. If you want to go to Glacier National Park and hike onto a glacier or take your children there, I advise you to do it in the next decade or so because it's going to get harder and harder to access those glaciers. If you go to places like New Zealand where you have more low latitude glaciers, many of those glaciers like the Fox Glacier, Franz Josef Glacier, are no longer accessible by foot. I had the opportunity to actually hike up to those glaciers a few decades ago. So this just illustrates one example in Chile where the ice 30 years ago was there. 30 years later, it has retreated, same glacier has retreated back about 1 kilometer. Now this is hard to measure, but people are making attempts to take these changes in ice elevation and terminus of the glacier changes and calculate the total volume of water that's being generated by melting glaciers to come up with these kinds of patterns that show that we're actually losing mass over time. Now the 800-pound gorilla, and what I like to refer to as the 800-pound gorilla when it comes to sea level change, are the ice sheets, Antarctica and Greenland. If we were to melt the Antarctic ice sheet, we would raise sea level 200 feet. And if we were to melt the Greenland ice sheet, we'd raise sea level about another 20 feet. Antarctica is melting very slowly. Greenland's melting rather rapidly. So although it makes less of a contribution, its rate of contribution to sea level rise is faster. Now, when the first IPCC panel reported, this information wasn't there because even 20 years ago, we didn't know this. We didn't have the instruments that were precise enough to measure subtle elevation changes in the ice sheet. So this is all relatively new, and it's come along since the IPC, and it's showing that what we're looking at here are simply graphs that show losses in the size of the ice sheet, the mass of the ice sheet through time to show that in fact the ice sheets are getting smaller. The scary stuff is when you look at the numerical models that are being produced or being generated, where they look at changes in CO2 concentration and associated changes in temperature over the poles, and how that could affect the actual ice masses. And as recently as this year, early this year, there was a paper written by a couple of, this past year, a couple of well-noted climate modelers, ice sheet modelers, who argued that by the end of this century, with the accelerated mass loss of ice in Antarctica, we could easily see a sea level rise that's double the 1 meter predicted rate. So that rate's getting higher, it's not getting lower. Now here's the compelling evidence. If you take these independently observed phenomena, rate at which glaciers are melting, rate at which ice sheets are getting smaller, thermal expansion of the oceans, you add those up, they come out to within 1/10 or 2 millimeter per year, the actual observed rise in sea level. So the next time you run into a climate skeptic, show them this and ask them to give you an alternative explanation for how sea level has increased 5 to 6-fold in the last several decades, other than through global climate change. They won't be able to provide an explanation. One of the remarkable things about global climate change is how dramatically public opinion on the subject varies from state to state. In fact, you don't have to go to Seattle, Washington to sort of find people who are on board with global climate change and concerned about its impact. You can go right next door to Louisiana. It turns out that Louisiana is one of the most threatened states, certainly potentially the most threatened state in this country, certainly from sea level rise or global climate change. And the people that live down on that delta that is disappearing at the rate of 1 football field per hour, land loss, do not dispute global climate change and accelerated sea level rise because their ancestors lived on that delta and they know that the changes they're observing today are unprecedented, and that ultimately, by the end of this century, it's going to result in a configuration that looks less like this and more like this. That's New Orleans. So not a pretty picture. I always like to say that Louisiana is in intensive care. Texas, we're in the waiting room. We know we think we've got a problem, but we don't know what it is, and we got a lot of people telling us we don't have a problem. Now there's other things, again, I won't go into, like warm undermelting of ice sheets by warm currents. This actually turns out to be the greatest threat from global warming in terms of sea level rise and impact. These warmer ocean currents flowing up under ice shelves and melting those ice shelves at rates that are truly extraordinary. Well, about to finish up here, but I did want to just say a couple things about the education side of things. It's interesting to me that our politicians, and especially our politicians in Texas, don't even seem to be on board with the major oil companies. This is some statements issued by all of the major oil companies over the last 10 years. Some of them were later coming on board than others, like Exxon. You're all familiar with the Exxon holdout in terms of acceptance of global climate change, but they're certainly on board now, along with all these other companies. So all the major oil companies now fully recognize not only global climate change is real, that it is caused by humans, and that they need to start thinking about it if their companies are going to survive economically over the next several decades. Nothing to do with human health or whatever, just pure economics, which is what these companies are most concerned about. What are we going to need to do to reverse the process or to counter the process? This is I pulled up from a website, recent publication, and just basically here we are today. This is predicted carbon production, CO2 production, over the next several decades up to 2050. That's just following our current trend into the future. We're now about to increase that trend, of course, because now we've gone the other way around in this country. We're going to start producing more coal. We're going to start producing more oil shales. Those are high carbon sources. But to reverse the problem, what we need is, which can be done, and we're making progress. We have more efficient automobiles now. We have more efficient electrical conductivity. So there are modes of progress here, but there are things that are progressing less rapidly, like carbon capture. So the race is on to try to reverse the process. So in the end, how do we deal with global climate change? The biggest enemy we have in global climate change is ignorance. And a lot of that ignorance is in Washington, D.C. or in Austin, Texas. And so I've spoken to third grade classes. I spoke a year ago to my granddaughter's third grade class. I found them much more receptive in comprehending of the science than I have found when I've spoken to groups of policymakers. In fact, more often than not, when you go to Austin, and I've done so, it's hard to even get those people in the room to listen. So educate, educate, educate. That is truly where we have to go. And if we're going to change these things that are happening, not predicted, but are happening. Thank you.
Earth Sciences, WE School of Natural Sciences, Rice University, who has presented the conference, Educate to Counteract Climate Change. And in the name of the Global Embassy of Activists for Peace, we thank you yet again. Doctor, I was given a question, and I would like to see if you could possibly answer it.
Sure.
The question is, with your expertise and in your personal opinion and fact, what is it that humanity must do to take an affirmative action at this point to counteract the climate change? What would be the steps necessary to do so?
Well, activism. I think when we hear absurd hypotheses like global climate change is a conspiracy of Chinese businessmen, we owe it to future generations to speak out. And those aren't I mean, in this state, we're devoting more attention right now to who uses which bathrooms than we are to health issues, as our last speaker pointed out. Again, not predictions, but current health issues related to global climate change, to severe issues with water shortages in this state. So that we have many issues. We're seeing barrier islands disappear at phenomenal rates. So we are seeing some severe impacts to global climate change. We're still in denial. I call Texas a state of denial. And we're going to have to insist as citizens, we're going to have to be activists. So that's why I like this group, you're activists.
And another question that was also raised earlier, you were speaking about the political agenda. What is your particular opinion, a law that should be considered to be proposed in favor of Mother Earth?
Thank you. Well, I was told in a talk I gave a few weeks ago that I wasn't supposed to be talking about politics. So well, that's interesting. I knew there was an issue with church and state. I didn't realize there was an issue with science and state and government. But I think as scientists, we owe it to the world, to the globe, to speak out. And so that's, first of all, my first comment. And I'm sorry, could you repeat the question?
Well, the question that was raised earlier was you were speaking about governance and how Washington is not doing its part. But in your particular opinion, what is it that you feel should be a law that should be proposed?
Well, we made tremendous headway under the previous administration, not only in this country, but globally. And we participated and we led in those global efforts. And the U.S. has consistently led the way in terms of global climate change research. If you look at numbers of papers published, citation, whatever index you want to use, the U.S. has led the way. We're going to lose that leadership edge now if we see funding reduced. You're not going to lose morale. If anything, you're going to make the science community madder, and they're going to work even harder, which is pretty much what we're seeing happen now. But I think the laws are there in terms of federal laws. Now in Texas, again, we have some issues. We have our own environmental protection agency. It's called the Texas Commission on Environmental Quality. Everybody says, oh, that's great. Well, it would be great if they were indeed not spending half their time trying to counter the EPA, which won't be an issue now that we're about to downsize the EPA. So I think we need to try to hold our ground as best we can, to be outspoken, to be activist in terms of trying to prevent reversals on pipelines, for example, that are really intended to stop that flow of heavy crude, really bad stuff from a carbon standpoint. Tar sands, things of that nature. Reopening or initiating the coal industry, we'll see an upswing in the coal industry now. That's not good. So we just need to be more outspoken and try to protect and defend the laws and the agencies that are there to, like the Environmental Protection Agency, NOAA, the U.S. Geological Survey. There are many agencies that are charged with making sure these laws are upheld, and we need to make sure that that's done. Unfortunately, that's going to be a real uphill battle for the next 4 years.
There's been a final question that has arose. What is your view on the indigenous people, and do you believe that there is a lesson, or perhaps, for lack of a better word, maybe wisdom that we can take from them to better our environment?
Well, absolutely. I think I applaud your attempts to and your efforts to point out that humans have to live in harmony with the earth. I don't think you'll disagree with the scientific community on that one at all. And so there's a lot of harmony here between indigenous people and what the scientific community believes. It's unfortunate that, religious groups are not quite as active, or promote, because that's really, protecting Mother Earth is part of every major religion. And I heard the Pope speak out a year ago about protecting the earth. But people aren't listening. And so the question is, how do we combine the indigenous people, their philosophy of protecting Mother Earth, religions, which at least have it in their charters to protect Mother Earth, how do we work together more efficiently, in which case we could become much larger, much more powerful voice to protest some of these changes that are going to be counteractive, definitely going to be counteractive. If we don't see a change from what is proposed for the next 4 years, we are definitely going to see CO2 increasing significantly by the end of this 4 years. Hopefully it's only 4 years. So again, I applaud the indigenous people's efforts. I think, and would encourage you to be activist, to speak out, because this is, I think, the most important, in my opinion, by far the most important thing we can do for our children and our grandchildren. We think we have problems now, but they're going to have serious problems to deal with. And of course, as we all know, a lot of indigenous people are living in areas that are going to be severely impacted by drought, water shortages, health issues. They're going to be impacted probably harder than anybody else, certainly in North America.
Thank you very much, Doctor. Big round of applause.